product rule to find the derivative of this function because the two functions are separated by multiplication. So the product rule, second function plus the second function times the derivative of the first. So now we're going to write that. This is your product rule laid out. So the next step would be to write it again, but with the derivatives rather than the notation. And this is the derivative of this function. And
so to find the derivative of this function, you would need to use the quotient rule. And you would need to use the quotient rule because it is two functions divided by one another and they both have variables in both the denominator and the numerator. So you will use the quotient rule, which is low times the derivative of the high function minus the high function times the derivative of the low function, all in parentheses, over the low function. So you'll use the low function, 3x minus 2, times the derivative of the high function, 2x plus 5, minus the high function, 2x plus 5, times the derivative of the low function, 3x minus 2, all over the low function, 3x minus 2 squared, which should give you 3x minus 2 times 2 minus 2x plus 5 times 3, all over 3x minus 2 squared, which should give you, using the distributive property, you'll multiply both of them, so it should give you 6x minus 4 minus 6x plus 15, all over 3x minus 2 squared. So now, these two 6's will cross out, and your final answer should be, in f prime formula, negative 4 minus positive 15 over 3x minus 2 squared, which simplified would be negative 19 over 3x minus 2 squared.
okay, so for this one, we're trying to find the slope of a line tangent to the graph f of x equals 3 over 1 minus 7x at point 1, negative 1/2. And the way you do that is finding the equation of a line, you would need the point and the slope. What is the slope? The derivative, or the slope function is the derivative. So first, we are going to find the derivative of this. And because this is separated by division, you know you're going to use the quotient rule. So then once you rewrite it, actually having taken the derivatives, you get 1 minus 7x times 0 minus 3 times negative 7. And you get that because the derivative of a constant is always 0. And the derivative of a constant here is 0. And then 7x, this is 1 times 7, so 7. 1 minus 1 is 0. X to the 0th power is 1. So 7 times 1 is 7. So that's how you get the 7, and the negative sign stays with it. All over 1 minus 7x squared. And So the next part of this problem is to use the slope function, which is the derivative of the graph of the line, to find the equation of the line. So this is the slope, and in the point slope form, you need y minus y1 equals m, or the slope, times x minus x1. So in order to find the slope using this, we're going to plug in our x, which is 1 for these points. So slope equals 21 over 1 minus 7 times 1 squared. So we're going to 6. So now you have the slope equals 21 over 36, which can be reduced to 7. So what we have now is the slope function that we found by taking the derivative of the original function, and we have the slope, which was found by plugging in x, 1 for x in the slope function, which leaves you with 7 over 12. So the last step that you need to find the equation of the line tangent to this graph is to use the point slope formula, and all you need for the point slope is a point and a slope, and fortunately we have both. So y minus y1, which is -1/2, equals slope, so 7 over 12 times x minus 1. So the first thing that we're going to do is distribute over 12. So we distributed that, so now we have 7 over 12 times x, and then to subtract 1/2 from 7/2, we made the fractions have common denominators, which leaves us with 13 over 12. So here we're going to write minus 13 over 12. And this is your function for the line tangent to this graph.
So to find the derivative of this formula, you would have to find the derivative of each function first, and then work your way from there in adding the formula. So I want to use the power rule to bring x to the 5th to the numerator. So it'll be 2x to the -5th minus x to the 11th power plus cosecant times 4 minus 4 being the index and x with 3 being the exponent. So then it'll be 11x plus 0 because this formula right here, this function does not have a variable, so it'll equal to 0. Then this function right here would be x to 3 over 4 because inside of the square root is the numerator. The number on the outside of the square root would be the denominator. And also you subtract this from 1 over 1. So it's -1 over 4. And this will be your answer in x prime formula.
So what are you going to do when your calculus teacher gives you a function like this and says, find the derivative? You would use the quotient rule, and you know that because these two functions are separated by division. So whenever you see a division sign, you know that you need to do the quotient rule. Simply stated, the quotient rule, you would do low times the derivative of the high function minus high function times the derivative of the low function over low squared. What do you mean by all this? For the functions, these particular functions, we would do 3 minus 2x times the derivative of 2 minus 3x minus 2 minus 3x on the derivative of 3 minus 2x all over 3 minus 2x squared. So this is the quotient rule, and you know that you use it because of the division, and you would solve this and end up with your derivative, and your calculus teacher would be very happy.
The product rule is a rule that is used to find the derivative when two or more functions are multiplied by one another. Using this product rule, one must find the derivative of the first function times the second function added to the derivative of the second function times the first function.
So what are you going to do if Dr. Lewis gives you this function and says, find the derivative? Well, you might be confused because this is a radical function, but we can make this problem a lot simpler by writing it in its exponential notation rather than the radical sign. How do you do that? You take the variable, and then since this number is within the radical sign, it's going to go on top of this fraction. So you're going to have 2 over 5. And now you have an exponential function. So what do you do when you have an exponential function? You use the power rule. And you just bring this down. So now you have 2/5 x times 2 over 5 minus 1. And whatever you get from that will be your answer by changing the radical sign to an exponent.